Welcome to the build guide for the AI008 matrix mixer from AI Synthesis. As usual, we're going to start low to high so that it's easier to manipulate the components as we put them on. And that means we're going to start with the two 10 ohm resistors. Now we'll move on to the four 1K resistors. There is a silkscreen error near the first output on early boards. It has already been corrected for subsequent runs. It says 100K, that's the one I just placed there, but it should be 1K. So if you built this and you're like, hey, how come output A is really quiet? That's why. Sorry about that. It was originally a standing resistor, and for some reason in my PCB software, when I convert from standing to a lying flat resistor, it resets the value to 100K, and I didn't catch it. Sorry. I don't know why it does that. It's very annoying. Now we're moving on to the 47K resistor. This is the feedback resistor for the op amp that sums the output. So I chose 47K just to make sure it wouldn't distort, because you could have quite a few signals running through, especially because you can combine them together. So there was a real opportunity for distortion if you were pushing all the inputs pretty hard and not attenuating the signals. If it is too quiet for your liking, you can push it up to 100K. Although if you do that, you could be sending like something hypothetically like 3 times as much gain as the op amp wants. So 47K is a nice balance. Now we'll move on to the 100K resistors. There are a lot of them. There are 25 of them spread throughout both boards. So just take your time and be patient. After you're done with this, the build is halfway over, a little more than halfway over. So it's a big step, but it's a bunch of resistors at once. That's not that bad. And here you can see that when it's really crowded like this, I'll go through a couple passes of soldering. I'll solder and clip off the pads that are easy to get to. And then if something's too crowded, I'll just skip that and do it after I clear the board a little bit. I'd rather do that than have run the risk of a solder bridge or a cold joint or something like that. I prefer just to take my time with it. Now we're adding the shrouded power header, all blurry in the background. We're doing this now because after this, we're going to add some components that have height but don't have a lot of sturdiness, namely the zero 0.1 UF capacitors. So by adding that shrouded header here, it's going to take some of that pressure off of those components when we're soldering them from the backside. I like to make sure it's nice and flat after I put one pin in, and then I solder the rest of them. Now we'll add the zero 0.1 UF capacitors. These are just there for power filtering. Now we'll do the two 14-pin IC sockets followed by the two TL074 chips that go into them. As per usual, what you want to do is make sure that the socket matches the orientation that's shown on the PCB. The PCB silkscreen has little divots, and the socket also has a divot. You want to make sure that those line up, because once the socket is in place, it's hard to see the divot on the silkscreen. So you're going to use that divot to help show you which way the TL074 quad amp op goes in, because if you reverse it, you will reverse power and the IC will explode, probably, or at least smoke. Once it's in place, I like to just use a flathead screwdriver to get the pins flat, and then I move on into soldering them. When seating the TL074, it can be helpful to just slightly kind of push the pins inward a little bit, and then just help them go in. They want to fit, so don't push too hard when you're first getting them in there. You just kind of gently but firmly press them in, and then once they are in, I like to make sure they're thoroughly well seated so that they don't pop out. Then we move on to the 210UF electrolytic capacitors. These are polarized, so mind the silkscreen to make sure that you get them facing the right way. The white stripe on the capacitors indicates the negative polarity, and these, again, are just for power filtering. Now we'll move on to the 4-pin headers. The headers I'm using, the female headers I'm using in this video have really long leads. The ones that come with the kits don't have those. I was just kind of using what I had before the kit parts arrived. So you won't need to trim them down the way that I will have to. When I put in headers, I like to go ahead and do both sides, get the headers fully in place and make the sandwich board before I solder. That way I know that they fit and that they're in place, and it makes it a little bit easier, in my opinion. They don't accidentally end up bent or askewed. And again, right now we see those long stackable pins. Those are not on the parts that come in kits. Now we'll go ahead and do the jacks. You can, if you want, put in the PCB spacer that goes between this panel PCB and what I call the board PCB. At this point, I like to wait until just after the jacks are done. The jacks are close, so what I like to do is just put in the vertical pairs, and then going in the middle, just solder in the ground lugs and only the ground lugs. Those are the pins that come out from the side there. I'm basically just tacking them down, and I'm doing this because this means that gravity is going to help me make sure that those jacks are nice and flush against the panel PCB, and then I can turn it over afterwards, reflow the ground pins if needed, and do the other jack pins. But because it is crowded, I like to just go in vertical pairs and get the ground pins when they're easy to get this way. Now we turn the PCB over and we hit the lugs that we missed, which would be the signal lugs and the switched lugs, and then reflow the ground pins if needed. So in this video, I actually don't add the rear PCB spacer, but this is a good time to do that. I am adding the other thing you should add, which is the panel spacer, because the next step is the potentiometers, and those potentiometers don't have the same resting metal body that is at the same height as the jacks. So we're going to need to make sure that this spacer is there for the panel to sit on, because we need the panel to be at least slightly in place in order to make sure that the potentiometers have a good turn ratio and aren't brushing up against the panel. So you just take the potentiometers, and sometimes they pop right in. Other times you need to kind of just slightly squeeze the side connectors. They don't actually carry any signal. They're just there to help keep the potentiometer in place. So yeah, you can see him using a little mini screwdriver to kind of help get that guy in place. And just go ahead and place them all. We want to wait before we solder them, because we want to make sure that that the panel fits on them nice and straight, so that we don't accidentally solder them askew or anything. So now we're going to carefully place the panel on, making sure that we don't knock anything out. Just takes a little bit of patience, nudging potentiometers into place if they're slightly out of place. kind of easier if you go from one side to the other horizontally. And there it's on. And then we're going to go ahead and screw in that top screw that holds the panel in place so that the panel's nice and firm against the PCB. And that way we know that if all the pots have good turning ratio, that they're good to solder in. It is kind of nylon into nylon, so it may take a couple turns at first to get the screw going in there. And now I'm testing the potentiometers to make sure they all have the turn that I want and that nothing's rubbing up against the panel. And it's good to go. So now it's time to solder in all of the pots. And if I were smarter, in this view, we would see the spacer that comes from the panel PCB awaiting the board PCB. But I didn't do that in this video because I was actually using the prototype. I wasn't actually sure if it would work. I was pretty sure it would work, but I hadn't built one of the new prototype production-ready boards yet. Now we're about ready to go. So it's time for the continuity test. Put your multimeter in continuity mode and make sure that you don't get sustained beeps when you're touching negative to positive and negative to ground and positive to ground. Assuming you don't have any beeps, you're good to power on and test. That's it. It's available as a kit or PCB panel set at aisynthesis.com.